Hello students, in this lecture we shall understand the concept of abstract classes. Abstract classes are those classes which by name suggest that they cannot be instantiated. Instantiated means we cannot create objects of these classes. So what does it mean in case there is a class in which we cannot create an object? Suppose here in this example we are having a public class 1. So because it is a normal class, we are always able to create an object of it. Like, name the class ob is equal to new ob. It is always done. So in case we try to save this and try to run this method, JavaC 1.java, we'll see that there is no error that comes in. Why this is coming? Because we have named the class wrong. Let us run this program again and we'll see that there is no error. So let us see what if this class is public and abstract as well. So in case we use a keyword abstract before the class, this class can be termed as abstract class. So let us see what happens. So in case we try to compile this program, we see that the error is coming because one is abstract, it cannot be instantiated. So we cannot use this new keyword while creating an instantiation of an abstract class. So in case the class is abstract, and we cannot be able to create an instantiation of it, what is the use of this class? The use of abstract classes are that they can be reused in the way like we can inherit new classes from this. Like for example, in case we want to create a new class 2 which is extends from this one class. Now this way, this is true. Now this class 2 which is inherited from the abstract class, and this class is right now not abstract, and right now if we create this main method here and we try to create an instantiation of this 2 class, you will see that now that we'll be able to create an instantiation. Let us compile this program. Let us remove the first one in case in which we were trying to create an instantiation. Compile the program, and when we try to interpret the 2 class, we'll say that this is quite possible. Now that we are able to create an instantiation of this 2 class. Now this abstract class which is actually abstract, what exactly do we mean by this methodology? Once a class is abstract, it means that there is no physical instance which is actually be able to connect to it. Now until or unless we create an instantiation of its subclass or derived class, we will not be able to create an object of it. Now the relationship between 1 and 2 is that this 2 class we have been able to make it concrete. So this is a concrete class of which we can create an object, not of the abstract class. Now what is the structure of? We should actually understand the structure. Now what do we mean by structure? Structure means when 2 is inherited from 1, what actually it is inheriting, because there is nothing that is given in this abstract class. So abstract class structure says that it can have certain methods as well as the properties too. Now what are the data members? Can I give a data member to an abstract class? Yes, of course we can. We'll be able to say it through an experiment, as well as there are two kinds of methods which we can give within this abstract class. One, the abstract methods, and the earlier and the new ones, they are called as non-abstract ones. So earlier versions were saying that we can have only abstract methods within the class, but now that we have been able to create both the category of methods within an abstract class, even if there is no abstract method, as you have seen, we are not able to create an instantiation of this class. So just by giving the name as abstract and providing some data members and non-abstract methods too within this class, we will still say that the instance of this class cannot be created. Now we'll see through an experiment how we can add up certain members as well as abstract and non-abstract members within this class, and they are reused. Now let us add one data member to it. So suppose I add a number and a method which is actually abstract. So in case if it is abstract, we'll write abstract before it. Abstract void call me. In case the method is abstract, what does it mean? It means that we cannot have a body of this method. Like writing this will be giving you an error. So in case the method is abstract, we just will actually end up with a semicolon. That means we just need to give a signature of this method only. There is no definition that can be provided with an abstract method. Now let us add one non-abstract method. Like if I add call me to. Now this method, because it is non-abstract, it needs a body to be given right here. Now let us add certain statements into it. Println, and let us add the value of the data member. Value of number is. So it is doing what exactly other data members and other methods which are non-abstract they actually do. So this method, because it is a pure data member function within this class, so this can actually access the data members, so as it is doing. Now let us actually see whether these three methods, what happens when these three methods are inherited. So in case I do not make any changes within this class 2, you will see that there is one error that will be coming. What type of an error that will be coming? I'll just show you and then we'll rectify. Now this class that is extending from this one, it actually has inherited the non-abstract members like number and call me to. But this abstract method, once it is inherited, what happens to? So let us save this method and try to compile. Also try to compile this method, the error would be coming that 2 is not abstract. So this 2 class is not abstract and does not override abstract method call me. So it says that it does not override this method call me. So this call me, which was abstract, the rule is that anytime a new class is inherited from an abstract class, it must define all the abstract methods which are defined in the abstract class. So let us define this method inside the derived class. So in case we need to derive, we had seen in the method derivation that we should have a similar kind of definition that could be given. But another thing that we need to give is we need to omit this abstract tag. So the method, once it is defined in the derived class, it no longer remains abstract because we are giving body to it. So this method too can be given certain statements. So let us add one new statement to it. So this is exactly doing what? It is trying to print the value of number. So where from this number will come? It is coming through inheritance. So let us compile this program now that the abstract method is actually inherited. So let us compile. So now that this says no errors because we have actually implemented the abstract method into it. So let us run this to class. It runs. So because we have not made any call to this call me, that's why it is not show out no output. Let us make a call to this method call me, as well as we'll also make a call to call me too. So this is an overridden method, and this is a method that has been exactly inherited in its true sense. So it is a copied method within the derived class. So let us compile the method again. Let's run it. You'll see that both the members, both the functions, they are executing and giving you the output, because number is not initialized, that's why it is giving us 0. So this is how we see that an abstract class is defined. So what we can extra do it with abstract is that from an abstract class, what we can do is we can derive new concrete classes, and not even concrete, we can derive new abstract classes even. As we had seen, in case this class 2 was not able to, in case there is no definition of this call me, so this class 2 actually should be given as abstract. So in case you want a class as abstract class, a class is inherited from an abstract class, and you want the class 2 to be remained as abstract 2, so it is not mandatory to define the abstract methods of the base class. You can leave it as it is. So from an abstract 1, you can actually derive a new class, that is 2, and from this 2 you can derive a non-abstract class, which is 3, suppose. So in case this is 3 is concrete, so then the duty of this 3 is that it should provide the abstract methods of this class as well as of this class. So all the abstract methods of the top class, which this class did not define, they must be defined within this 3. And in case this abstract 2 class is also having its own abstract method, so this 3 class must implement that too. So this is how the abstract classes are used within Java. So this is a very important topic. We also will see how the interfaces actually imitate the abstract classes in Java. We will define interfaces in the next video. Thank you very much.